Today we will discuss the business application of normal distribution, the blueprint of uncertainty. We are dealing with probabilities, turning statistical variance into management superpower. How we can apply the mean, variance, standard deviation for precise business predictions. In the early stage of studying the probability, statistics, more specifically statistics, we deal with the raw data and unorganized data, uncategorized data. Then we organize the data in the form of ascending order and descending order, and then we find mean, median, mode, that sort of thing we discussed. And then we move to the next step. We try to group them. We try to categorize, right? Group them, group the data. And then we studied the group, right? For me finding the mean, median, mode, standard deviation, variance for group data. And how do we visualize data? Cumulative frequency, or guy, right? Or guy more, or guy less. So we discussed things. And then we start our session with probabilities, right? Uncertainty, right? Uncertainty, and we discussed some the basic concept, basic rules, basic properties, addition rule, multiplication rule, mutual exclusive, independent event, right? So this kind of things we discussed, and then we move to discrete probability distribution, continuous distribution, and then binomial distribution, Bayesian distribution. Now we are in the normal distribution. Normal distribution, how we find the probability? It's area under the curve. Keep in mind, area under the curve is equal to 1. We assume, right? We proved area under the curve between given range of the variations is area under the curve equal 0. Area under the curve equal maximum, right? 1 total, and it's never below 0. Right. This is in that form, the raw data here, right? Product, it may be the product weight, it may be the delivery time, it may be student marks, it may be customer arrival time. So any form in unorganized manner. It's raw business data, raw business operation data. Now we convert them into a systematic pattern. We can recall, we have studied, especially in the group data, how we draw the histograms, right? It's a histogram. When you look at the in-depth view of normal distribution, we can see there are many tiny histogram inside. There are many tiny histogram. And you know that here, this is the highest number of frequency. Here we can show frequency, so the X values here, and this is mean, median, mode, the symmetric, right? You can remember that we have studied the skewness, right? Skewness, symmetric nature. So left side should be equal to right side, and here mean, median, and mode are equal. Right? These things we have discussed. Right? Here, when aggregated random operational variations from highly predictable symmetrical pattern, the normal distribution has this property. Right? Look at here, most of the observations, right? Most of the observation here at the center. Here, this is the mean. No, this is mean. Most of the observations fall under the mean, right? Falls below, right beside the mean, converge to the mean. And we can recall some of the properties of normal distribution curve. Strategic operation. The normal distribution as a predictive tool. Now, since the statisticians observe some common patterns among the data distribution, and here this is the mean, right? It's a mean. The means expected value. Mean means expected value or the target value. The expected targets mean represent the intended goal or the most common outcome of a business process. If it is an exam results, exam marks, mean. I'd say 70 marks is the mean. Most of the students will get marks within this range. So most of them are from 65 to 75, right? In this range. Here, most of them are here. So assume that this is what there are a lot of tiny histograms. It's a histogram. There are a lot of charts, bar charts, column charts. The inconsistency, some, right, even though the average mark 70, some students may get extremely high marks or extremely low marks. So those are variations, right? These are the variants. Here, this pattern, right here, the marks, the students' marks, here converge to the mean. Most of them are here, but we can observe some of them are here, right? Extremely, not extremely, it's far from the mean. Inconsistency represent the natural error margin of the process. The narrow curve means the high precision, and the wider curve means chaotic operations. Here, the standard deviation. I will explain you when we study earlier about some things here. When we study mean, standard deviation, variations, right here, this is what we compare this. This is the top mean. This is standard deviation. When variance, when we observe high variance, it's like this. Here mean, but it varies much, and it's very here very wide. So wider means more variation, narrow means low variation. That variation measured using the standard form is standard deviation. Center point is mean. The total reality at area under this curve, area under the curve is 100%. 100% probability. Represent every possible outcome, or every possible future outcomes. To calculate risk opportunity, managers simply calculate area of specific slices under this curve. For example, if management wanted to know how many students marks here below, say 50 marks, how many students below. So they can predict, like in a A-level competition exam, A-level examination, we get the Z score. It's based on this principle. Management dilemma, comparing uphill storage. A business may have different operations, and they have to make different predictions. Here, for example, milk manufacturing production. They produces milk packet, so on average 400 grams. Sometimes the packaging machines has some natural variations. It may be sometimes more than that or less than that. It may varies like 5 grams more or minus 5 grams, less 5 grams. That is mean 395 to 405. So there are small variations. And logistic delivery service company may deliver their product within 24 hours. Sometimes it may varies. Sometimes it may early, sometimes it may little late, and they can predict what is the probability of delivering the item before 20 hours. And what's the probability of getting delay? It's been more than 10 hours. Like that, they can predict. And human resource, they can measure the employee performance. On average, they may get 56. On average, some employees may get score 70, 75. Some employees may get 40, 35, like that. How can a CEO evaluate 6-gram manufacturing error? Here, they are producing 400-gram packet. And the management wanted to find the chance of getting 6%, 6 grams plus or minus error. What's the probability? Say 406 and 394. What's the probability between this? And 2 hours shipping delay, delivery, normally 24 hours, it may be 26, or the probability of getting 2 hours delay. We need a single universal scale to measure abnormality across entire company. Here, normal distribution, we are going to apply normal distribution. So a business scenarios having a different properties. Here, properties mean we have to focus on mean and standard deviation, average and variation. These two things is enough to make prediction. Right. Here, you see, in this business scenario, they are using grams. This scenario, delivery hours. This scenario, scores. It has, right, different things, different properties, different business context. But we have only one table. We have only one table. What is it? Normal distribution table. Here, we have only one normal distribution table. Why we can apply this one normal distribution table? This is standardized, right? Standardized normal distribution table. As I explained, as we discussed earlier, many business scenarios can use the normal distribution table. Then many of you may have questions, right? One business scenario, they are dealing with grams. Another business scenario, they are dealing with hours, delivery time. Another business dealing with the score, HR score. Another thing, student marks. So they have different context. Then how we can apply this distribution table? So that is why we use a term, what? Standardization, Z. Z means standardization, standard normal distribution. Now, let's see here how we are going to standardize a value, a random variable. Yeah, x is the variable. X is the variable. It may has a lot of different properties. It may have different mean. So it has mean and standard deviation. Now we want to convert this x value into a standard value. The x may have different for the manufacturing of milk packet, it has grams, 400 grams, 6 variation, and delivery time 24 hours the mean, and it has a different 2 hours delay difference, right? So it has different things. Then we have to convert them. Z, it's standardized. X become Z. Unstandardized become standardized. Here, how we convert this one? Very simple. X minus x bar divided by standard deviation. Sometimes we may use here mean, mu, right? So the Z equal x minus the mean and is to be divided by standard deviation. So in this process, any value of x become Z. Here, the universal translator, the set score machine. Step number 1, the raw input. What's the input of x? X is our raw input. The specific business metric you want to test, the x value we have. And then we have to deduct, right? We have to deduct the mean from the x value. So minus baseline adjustment, right? Minus average, mean, mu. Subtract the expected target from the x. How far off target is the event? So it's variance. How far it varied from its mean. How the x variable, x value varied from its mean. And should be divided. Should be divided by standard deviation. Here, step 3, the calibrator, we calibrate. So we found the differences between x and the mu, and then we divide the differences by the standard deviation. So calibration scales the error relative to the normal operational variance. And finally, we get z's value. You see, the x value become z. So this is the process. Step 4, standardize output. The set score, the universal metric showing exactly how many steps an event is a format. Now let's see here the business scenario. We had three business scenarios. Now we are going to aligning to the reality single master scale. You see the manufacturing of milk packet. Milk packet mean is 400. And logistic mean 24 hours. This is gram, this is hours, this is score, 56 HR example. Now, when we convert them, the mean, the average becomes 0. Average become 0. That's why when we standardize any value, right? Any value, for example, if x variable follow normal distribution, it's with what? It's with mu and variance. Mu and variance. Now it's become standardized, then x becomes z, it normal distributed with mean equals 0 and standard deviation 1. We converted that, right? X become 1. So therefore, you see here, the mean, right? The mean value becomes 0. And here the deviation. So these are the how far it deviates. For example, this value, this x value, how this x value deviate from its mean. And this deviation is standardized. Here, standard deviation 1, standard deviation 2 plus 2. Here, standard deviation minus 1, standard deviation minus 2. Now, this is the ruler, universal ruler. In any business context, we can apply this Z. Your marks, your A-level examination marks converted into Z. Once any business metric is translated to the Z ruler, we can use the single universal probability table to calculate the exact risk and outcome. Right now, this any business scenarios, X values become Z, we can use the normal distribution table, right? This table. Wait. Right. Yes. Okay. There's a power cut. And now I connect with mobile. Okay. Right. So now we can apply the standardized normal distribution. So this standard normal distribution table can be applied any business scenarios. Right. Now we move some of the business applications here. Worked example. A milk powder packaging business application. A milk powder packaging. A milk powder packaging company fills its product with a target weight of 400 kilograms, 400 grams. The target weight is 400 grams. Owing to a natural variation of the machine, the weight of each packet may vary slightly. The weight we assume x of a packet is given by the mean is 400 and standard deviation is 6 grams. Mean 400 grams and standard deviation 4. So how we can write this? X approaches normal distribution with the mean 400 grams and standard deviation 6, no? So variance 36. Variance 36. The company wishes to determine, right, what proportion of the package weight between 395 grams and 410 grams. The company wanted to know the probability that the package, the milk packets between 395 grams and 410 grams. So what's the probability? How we can find it? Now, the values are given in Z value, in X value. We have to convert them in a standardized format, that is Z value. You see, as I told you earlier, when we deal with this kind of questions, we have to sketch the curve, the normal distribution curve, sketch the curve, right? Remember, always the mean value is 0, the in Z 0, here in the middle, here 400 grams. Now we want to find 309, the probability. Here 309, here somewhere here 395, and 410 somewhere here. So we want to find the probability. So area under the curve. Area under the curve equal the probability. And we can find using the integration function, we know, but we have a standardized table, and we can apply directly. So for that we have to find the Z. We have to convert them, these weight X values, into Z. We know that this mean always 0, and we want to know what the Z value of this, and also we want to know the Z value of this, right? So here we want to convert first. We will convert this 365 into Z value. How we can convert? Here Z equal x minus mu divided by standard deviation. Here in this case, x value is 395, and the mean value is 400, and standard deviation equal 6. Then mean equal, or the Z equal what? Z equal here, it's very simple. Here, sorry, 395 minus 400 divided by 6. So,
Sir,
yes,
400.
sorry, there are some mistakes. 5/6, 0.833 something. 5/6, something wrong here. What's the value? 0.833, is it right?
Yes,
Is it
sir.
right?
Minus 0.83.
0.833, is it right? 0.
Minus
Yeah, minus 0.833. Is it right? Is it correct?
Yes, sir.
Okay, now we mark this value 0. My laptop in energy serving mode, so the performance may be reduced. And here minus 0.833. And now we convert this value 410. So Z equal X 410 divided by minus its mean 400 divided by variance 6. Here the variance is 10 over 6. Then what's the answer? What's the value?
1.66.
Here 10 over 10 divided by 6. 1.667. Z equal 1.667. 1.667. Right. Here, this is Z equal 1.667. Now we can find the probability. In the table, we can use here this one 0. This is 0 to 1.667. We assume area equal A. This area equal B. And now let's find the area A in the normal distribution table. 1.667. 1.666. That's 66 here. 1.66. That is 4515. This is 4515. And this, so we can use the calculator. So already in the statistical mode, one sample. Stat pi distribution. So we want 0 to Z. So therefore we can use Q. That is what? 1.67. 667, no? So actually this is 45224. Now we'll find the table. You can see 0.833. 833 will be equal to 29. Area B equal 29 0.29758. So if we add this B and A equal, we can get what's the value? Probability here 0.29758 plus 0.4515 equal almost 74.90%. So the probability of getting the package between the between 495 grams and 410 grams is 74.9%. So that's what it's given. Milk packaging here, this is 395, so 410. Here the probability at 75%. What does it mean actually? Interpretation is 74.92% of the total area falls between the standardized boundaries. Exactly 3/4 of daily production is in the market ready. Right? Now we move the second question. What proportion of product packages? What proportion of packets weight less than 412? Right? Less than 412. Less mean what? Less. Here we sketch. We know that this is 400 mean and 412 should be here, right side. And less, no? The proportion of the package weight less than this area. We know that this area is equal to 0.5 and we have to find this area, but anyhow we have to convert this value into the normal distribution table. Normal, we have to standardize them. Here this is 0 and we have to find what is the standard value z. So that here x minus x bar, no, x equal 412 and mean is 400 divided by 6. So we know that the difference is 12. 12 over 6 equal what? 2. Now we know that z equal 2. Z equal 2. So the 2, you see 2 in the table, 2 equal what? 2.0. 47, 72, 4772. 47, 47, this is for 4772. So therefore, we know that this is 50%, this is 47.7, 47.72, therefore, how much? 97.72% of the product. The probability that the weight is less than 412 is 97.72. Here you can see, right? You can see here. So this is 412. Here less than this area. Approximately 97.7 of the package weight less than 412. And the next question. What is the package with more than 419? Package, the weight is more than 415 grams. It's very simple and straightforward. We can draw. This is 400 and 450 is always to the right. And it's a more than mean here. More than. So in the table, we have this area. Before that, we have to convert them into z. We have to convert, how we convert? X equal 415 minus mu 400, standard deviation 6. So the difference is 15 over 6. Yeah, 15 over 6. 2.5. Now we see the probability of 2.5. 2.5. So the area, this area equal 49.38. And so we know that the total area to the right from the 0 is 50. So the difference is what? 1.5 minus 0.5 minus answer. is equal only 0.00621. See the answer? Yes. The answer is what? To the right? 0.00 0.0062. So when we depict in the graph, in the picture like this is 415, 415, set 2.5 to the right. Or we can apply directly. So this is the right side, no? Right side. We can apply directly without deducting from right. So this is R actually. Set 2.5. See, we get the same answer. We don't deduct. And for the before, the previous question, so to the left side, no, we have to find the area to the left. So we can apply directly here y, and this is actually p. So one. Also t value is 2. T value, z value 2 equal 97.725. You see, 97.725. So we can use calculator for these instances, but without table, facing examination question is very difficult. And here, why is that? You see this question, we can use the calculator for finding the distribution to solve this. Here, you see the question number 4, business decision. They won't reject 1%, 1% of the product. Any product that falls below 1%, 99% of the product weight will be, probability will be qualified the product, qualified for delivery, but 1% of the product will be rejected. Then we have to decide what is the weight of that packet. Then it's very simple. It's very straightforward. Here we have to find out the probability. The company cannot send underweight pack to the market. Therefore, it decided to reject the lightest 1% of the product. Here, so this is mean, the 400 is a mean. Any weight above this 400 grams falls here, right side. And any weight below 400 here. Here, they won't reject the packet which are less weight, which are less. So they want to find 1% of the product, less weight product. Here, we know that this is 50% and this is right side is 50%. But we want to know only 1% of the product will be rejected. So therefore, this range is 49%. 49. Here, 99% of the product will qualify for the market delivery, but here 1% has to be rejected. And we should know at which grams, at which weight we have to decide on which weight we have to get the rejection decision. For that, here we know that we know that in the table we have only this value. What's the value here? 49%, 0.4900 we have in the table. Now we will trace where is it 49% in the table. Look at here 49, 49, 49. Yes, here 49 and yeah, right. This is 49. So what is that score? 49, 2.3. 2.33, this one, right? 2.33, where Z, right? Z 2.33, where the area is 49, right? So we found the Z value here. We found the Z value, that is, this value is 2.33. But by keeping the Z value, we can't take decisions. We have to convert them into X, the gram. Here we know the formula, Z equal X minus the gram, the mu divided by standard deviation, right here, mu. Here we don't know the X value, we have to find it. And the mu, we have 400, standard deviation is 6, but Z we know that 2.33. When we solve this, here, this 6, no, this is 6. So 6 into 2.33 equal X minus 400. Now, X minus 400 equal 6 into 62.33, 19.38. So 13.98, 13.98. So X equal, that is very simple, it will go that side plus. But keep in mind, this is minus, right? This is minus because here into the left, no, to the left side, so it's minus. I'm sorry, forgot it. So actually this is minus 19.38, 19.38, and so we bring this here, now is 400. Now 400 minus 13.98 equal, now we can found X equal 386.02. So any value, any grams, right, any packet that falls below 386 grams, 386.02 grams will be rejected. You can see here that is only 1% of package less than 386 grams, those packets will be rejected. Right, this is example 1, and we use another example. Okay. Delivery time, customer service operations. An e-commerce company has found that delivery time is generally follows a normal distribution. Here, delivery time assume as X, mean 24 hours, delivery time 24 hours, standard deviation 4 hours. So therefore, we can write is X approaches normal distribution with the mean of 24 and the variance 16. The question is, the company wishes to determine what is the proportion of orders are delivered between 20 to 30 hours. So we know that the mean is 24, and we have to find the probability that between 20, this is 20 and 30. we have to find the probability. It's very easy, right? Here we have to find the z of z value for 20 and z value for 30, and then we have to find the probability of this one, say this A and this is B. We have to find the probability of A and probability of B, and we can add together, we can find the total area. That's straightforward. And the second question, what's the proportion of orders? What the proportion of orders are delivered within 18 hours? Within 18 hours. Yes, within 18 hours. Less than, right? Delivered within 18 hours. So it's very straightforward. We can draw this. This is 24, and within 18 hours should be here, within. So we have to find this probability, and in the table we can't find the probability the table by using the table, but we can find this. So we know that the left side is 0.5. So if we find the probability of this area and we deduct this A from this 50%, and we can get the probability. Otherwise we can use calculator P, right? The P, and we can find it directly. Now we find the Z value of this 18. Now Z equal X equal 18, mean 24 divided by standard deviation 4. So that here 18 minus 24, 6 over 4. Now we can find 6 over 4 equal 1.5. This is one set equal 1.5. So this value is 1.5. Now we use, you know how to use a table. Now we use directly, we apply calculator. Right. And this left side no to the Z. So we can use the P. That is 1.5. It's equal 93 point. Sorry, actually it's a minus. Actually it's a minus value. It's equal 0.0668. So it's mean 6.68% of the chance to deliver the item within 18 hours. Clear? Is it clear? You see the same answer, 0.068. Is it clear? Okay, now we move to the third one. What's the proportion of deliveries are late exceeding 32 hours? Exceeding 32 hours. It's also straightforward. This is 24, and here 32, and later, right? Later than 32 hours. So we have to find this area, and this represent R. And before that, we have to find this value, Z value, and X is 32, and mean 24, and standard deviation 4. Right? So here 8 divided by 4 equal 2. So this is the right side, no? Right side. And this is R. R equal to, well, the chance is what? 0.02275. So 2.275% the chance. here, right? Here is given later than 32 hours is what z equal to. So therefore, approximately only approximately 2.28% of the deliveries are delayed beyond 32 hours. Okay, give me 5 minutes. This is one question. This is what this application exactly. We can apply this to. And normally the government UGC apply this principle to set the cutoff. So by understanding this example, we can understand the mechanism behind the cutoff set score. Here, examination score. The score of 800 students. How many? 800 students. N equal 800. Students in a mathematics examinations are approximately normally distributed with the mean 56 and standard deviation 8. We have to be very careful. Is it standard deviation or variance? Right? Here now we can write it. X is the marks approaches normal distribution, mean 56 and standard deviation. So variance 64, n 800. Now, since the marks are rounded to integers, continuity correction is applied. This means here their marks, they put like this 56, 57, 58. So these are integers. Normally, this is how give the marks. But actually, this follows this, even though the marks given in the integers, discrete variable, but reality, in reality, this is what? This is continuous variable, continuous distribution, continuous variable. First, the number of students scoring between 50 and 60. We have to find the number. Earlier, we found the probability. Now, we find number of students. Right? We have to apply the probability to the numbers, exact numbers. Here, this is normal distribution. No? Normal distribution. We know that mean is 56, and we want to find how many students with they're getting marks would be 50 and 60. Here this is 50 and this is 60, and we have to find the probability. The probability, we have to find the z values. We have to convert these x values into z. Then if we convert into z, here x 50 minus 56, standard deviation 8. Standard deviation 8. Then we can find the z. And accordingly, here we can get 6 over 8. But keep remember, we are dealing with continuous variable. But it's given integers, but we have to convert them into integers. It's been continuous variable. Here, with the continuity corrections, we have to round at 50 and 60. Here, this integers, no, the boundary. We make it 50, we make it 49.5. For 60, we make it 60.5. So like this, no, earlier we have studied, no, the marks, the group data, upper boundary, lower boundary, like that. So here lower boundary of this 49.5, upper boundary 60.5. So rather than we taking 50 and 50 and 50, 60, we have to take the lower boundary here and we take upper boundary here. So this should be 49.5 and it should be 60.5. Then we have to find the the z value for this. actually. So if we convert into Z, for Z1 here 45, this is Z value is minus 0.81. If we find Z value for 60.5, the Z value will be plus 56. And when we look at the table, we can find the probability of this. And what's the probability for here? For A to 0.81, 29.10, and the left side, here 56. So this is right side, this is left side. And total area here 50.33. So right, the area is 50.33, but the question is we have to find the number of students who are getting the marks between 49.5 and 60.5, right? So we know that the probability of getting marks between this range is 50.33, but in the meantime we know the number of students is 800. So therefore we can find that 403 students may get this marks in this range based on the probability. Now we move to the second question. The number of students scoring exactly 65. Exactly, no? X equal 65. So remember, in the area under the curve, right? In area under the curve, any value of x equal any value, right? Say 5. So here x equal 5, for example. What is the probability of x? Is 0, always 0. Keep remember, right? We have already discussed this thing. We can find the area between any range interval. We can find the area in an interval, not in the exact point. The area in any area for any exact point of x is equal to 0. No probabilities, no area. Therefore, we have to approximate. The question is exactly 65. Exact 65 mean we can get small upper limit and lower limit. Here, what is upper limit? It's a class, no? Upper limit is 65.5 and lower limit 64.5. So that we can do like this. Here, the mean, this is 56, and we have to find the probability of getting 65. It's mean 64.5 and 65.5 in this range, right? So here students scoring exactly 65. In continuous distribution, p x equals 65 is 0. Therefore, with continuity correction, we take 64.5, 65.5. First, we find the z score of 64.5. We label them as Z1, that is 1.06. Step 2, we find the z value for 65.5 is upper limit, so that z is 1.19, and we can find the probability of this curve here. This is 64.5 and this is 65.5. The area, you know that in the table we can see the area is And then we can, again, we will find the area, this, up to this. And the balancing area will be this, right? Balancing area will be this. So therefore, first we find the area Z 1.19. So here area 1.19, let's Q no to 1.19 equal 38.1.19. It's equal 38.298 and 1.06. 35 point, this is 35.543. So if we deduct this one from this value, we can take here 3830, 3554. Then the probability of getting marks exactly means 64.5 to 65.5 is 0.0276, mean 2.76. Chance is 2.76. And there are 800 students. So probability of this getting marks of this 2.76. So therefore the probability 22 students, right? 22 students will get marks equal to 65, right? 22 students will get marks equal to 68. Approximately 20 students will get 65 marks. Then another question. So this is how university admission cutout is selected. Here, what is the minimum score to be in the top 100%, top 10%? For example, here there are 800 students here. Top 10 students mean top 10 percentage. Here only 80 students. 80 students will get the chance of getting admission to the university. 80 students will get the chance of getting university admissions. So what is the marks? What is the marks? We know that average is 56 and variance 64, standard deviation 8, and there are 800 students. Then how we decide? Only 80 students will get, only 88 seats are there. Then how we decide? This is how university admission cutoff marks are decided, set score are decided. Let's see here. I missed one here. Okay, you can take later. Right here, I missed this one. If the pass marks is 40, if the pass marks is 40, how many students will fail? Right. So in this exam, if they decide that the pass marks is 40, how many students will fail? Now we will find the probability. First, we will find the probability below 40, like this. So this is 56. If we decide cutoff marks 40 and any students falls under this area will fail, and we have to find the probability of that. And then if we multiply with 800 number of students, we can get the number of students who fail. So now we convert this 40 into Z. 40 minus 56 divided by 8. Then it's equal to z equal 2. Z equal to here 2, right? 2 equal 47. Z 2 equal 47 to 5. 47 7 to 5. And we know that this area, so this area 47 7 to 5, and we know that total area of 0.5. If we deduct this area, say A, then we can find this reject the fail marks. So it's approximately what 0. Right here 0.5 minus so 0.0275. 0.2275. We know that there are 800 students, and maybe 18.2 students may fail in the exam, right? Yeah, right. I made a small mistake. 40, no, so it has to be rounded to 39. 39, right? It should be rounded to 39. In that instances, it's become minus 2.06. So therefore, the probability is 48.03, and the probability of getting reject fail 0.0197. So therefore 60 students will fail. So I forgot that. Okay, remember this is integer, but in normal distribution we use continuous. So this is 40. 40 is a interval, no, 40, right? So here lower boundary is 39.5. Okay, now we move this cutout. Find in the cutout what is the minimum score to be the top 10%. Only 80 students will get admission here. So how we can do this? Minimum score to be 10%. The top 10 mean right tail 10, right tail 0.1. Right here we know that this is 0.5. Here right side 0.5. We want top, so we want to find out the z. We want to find out the z, and also we know that the right side of the top 10%, top 10%, and here this is should be 0.4, and it is, so therefore it is what we know that this is 10%, so it should be 40%, because 90% here at this below this point that should be 90%. So we know that this is 50% and this is 40%, this is 10%, altogether 1. So in the table we can find the value of 0.4, right? 0.4. Where is it? 0.4. 0.4. Right, it's somewhere here. So that is what 1.1.238. 1.238. You can see 1.2, sorry, 1.28. 1.28. Here we found the z value. So this is what 1.28, right? 1.28. Now we apply this. Z equal 1.28 equal, we don't know the x marks, we don't know the marks actually, minus we know that average is 56 and standard deviation 8. So this is plus, we know that, right side. So that 8 into 1.28 equal x minus 56. X minus 56 equal 8 into 1.28. This is equal 10.24. Then x equal 10.24 plus 56. Then x equal 66.24. So the cutout marks is 66.24. So approximately 67, right? So answer, the minimum score to be the top 10% approximately 64. Likewise, how university actually UGC set the cutout. For example, if there are 100,000 students set for the A-level examination, but according to the rule, according to the sufficient capacity of state universities, they can accommodate only 6,000 students. 6,000 students to the university admission. Then, how do they find the set score? Here, first they have to decide the probability. Right? Only 6,000 students will get the admission out of 100,000. Right? Then, what's the probability? Only 6%. Only 6% of the students will get the university admission. So that they will decide like this. So z is equal to 0 and z here only 6%, top 6%. Only 6%, then they will decide what the set point is. How they decide set point? Right? Based on this 6%. 6% mean here, what is it here? 44%. What is 44%? 0.44. 0.44. Where is it? Right, approximately this one. The set score will be 1.55. The cutout will be 1.55. So this is a set score. Then earlier for example, economics, business statistics or accounting, or economics, accounting, and business studies. So they have mean marks, say 50 mean, and standard deviation, say 10. Accounting, they have 60 marks, standard deviation 5, and business studies 70 marks, standard deviation 10. Then they find their right. For example, Mr. Y. Mr. Y, uh, Mr. Y get the marks. Say his marks is 80 marks. He get 80 marks. Then he will get a Z score for this 80. How we get find 80 minus 50 divided by 10. Then 30 over 10. It will be 3. His Z is 3. Right? His Z is 3. And accounting, his marks may be 70 marks. Accounting 70 minus average 60, then mean standard deviation 5. Here 10 over 5. So his Z is 2. And business studies, he may get the marks of 75, then 70 and divided by 10. Yeah, 5 over 10, 0.5, right? Is 0.5. And what is Z score? Average Z score So altogether 5.5 by 3. Then what is 5.5 divided by 3 equal, his set score is 1.833. Cutout is what? Cutout is 1.55, but Mr. Y, his set score is 1.833. So therefore, this Mr. Y may entitled to get the university admission. By using your set score, there's a probability to find your actual marks. But the thing is, we don't know what is the mean and standard deviation. If you know the mean and standard deviation, you can trace your examination marks. I think now you can understand the logic behind setting the set score in your university admission.